Welcome to part 2 of Behind the Scenes, Polymorphism in Maana, where we are exploring how to implement polymorphism on type systems that don't support it. If you haven't seen part 1, there's a link down below, as well as a playlist. Where we left off is we have a function graph that does the coercion from the concrete type person to the generic type JSON, calls a reverse list function, then coerces the types back. And what we'd like to do is have a single lambda function that replaces all of this and would be generated by an assistant. So the user would simply select a generic function like reverse and then specify which types to specialize it for. And it will generate the wrapper function and wire it all in and provide the lambda logic itself. So we want to write this by hand the first time so that we can auto-generate it later. Now I could use the Lambda assistant to write this code, but it's going to be a little bit more sophisticated code. And I'd like to use a better development environment. So we're going to use Visual Studio Code to write the actual Lambda. And we're going to write some test harness code around it, and so we can debug it in a proper environment. So let's do that now. In Visual Studio Code, we're going to create a new file. And we'll call this generics proto.gs. And we are going to be using some async functions, so I need to wrap this in an async environment. Can call that, and just to make sure this works. And I can run this here, and there we go, we have hello. So let's think about what we want to do here. So what we need to simulate is the Lambda server calling your actual Lambda code. So the Lambda code is, well, in this case, it's reverse person. So I can go ahead and have a function called reverse persons. And this is an async function. It takes the input object. All Lambda functions in JavaScript take what's known as the input object. And the input object has the arguments of the function. It also has some kind of obscured or obfuscated objects as well, such as the CKG client, which we're going to be taking advantage of here in a second, because we need to call back in to the reverse function from our Lambda. In order to do that, you need the CKG client, and it handles all the authentication and will carry through the RBAC security. So the body of this is the Lambda entry point, and therefore the exit is here. And so we'll just say that this is, for right now, just going to return an empty array. So everything that we write between these two comments will be what we cut and paste back into our Lambda assistant. And we need to drive this with something that simulates what the Lambda server would be calling with. So what is that input object? So let's go ahead and define an input object here. And the input object is the x's. So we know that we have this field. And what are they? Well, it's an array. And in this case, it'll be of type of the people. So I've already written this code, so I'm just going to cut and paste this over. So you don't have to see me make typos. Okay, so this is just the two objects that we had before, Mary and Bob. And it takes this other obfuscated object that is it's known as request CKG. It's based on the request library, which is a simple GraphQL library. And all it does is take the query and the variables, as well as the service endpoint. So it's a pretty simple interface. And I've provided a fake stub here, and we're not going to call the real CKG in this little test harness here, so I'll go ahead and copy this over as well. So all it's going to do is simulate the reversal function. So this is really all the reverse function does, is it takes the input XS's and calls reverse on them, and then every GraphQL call has this structure. So the name of the function is also on the output object. So we're just adhering to that convention here. So this doesn't really do anything except dump the inputs and print them out. And then it attempts to call, we're just hard coding this because we know what we're building one specific function here. Okay, so this is the beginning of our little test harness with this faker for the CKG client. And then I would just simply need to invoke the lambda. So, well, we already defined that. So this is the, say const result, and we'll await the results. And that's just called reverse persons. And it will take the input object. Okay. So now we have our test set up, and we need to start making this real. So what happens inside of reverse persons? So I'll just make this clear here. This is all test harness stuff, and this is the actual thing of interest here. Well, there's two different parts of this. There's going to be boilerplate code that should be common for all of these generic operations or polymorphic operations that simply is doing the type coercion. That's going to be very common. And I think the way we can drive this then is by having like a little configuration object that provides the specifics. So I'll bring that over as well. And this part is generated by the assistant. So the only thing the assistant needs to do is create this configuration. So the elements that are needed are, we need to know which service it is. And I just copied this out of the workspace. So if you look at the workspace context, this is its ID. So you can always use that. The full endpoint is specified down here. But all we need is this bit. We just need the service ID because it's assumed by the CKG client that you're calling a service. So all you need is its ID. And we use GUIDs by default. When I created the workspace, I could have given it a better name, but I didn't. So I'm paying the price for that now. So we want to call the reverse function, and it's a query and not a mutation. So there are two different GraphQL query types. So I have enums for these. I'll just copy those over as well. So some constants defined. And we'll put them up here. So let's indicate where our boilerplate is going to start, because this is going to be common. So boilerplate start and boilerplate end. So this bit is always common to all of these types of lambdas, or these generic lambdas. And then this is the part that is specific to each lambda. So by dividing it this way, it's pretty clear. Oops, it's pretty clear, I hope, what needs to be written by the assistant in the future. And get rid of that return. We don't need that. Okay, so this is going to be a query operation, not a mutation. And the inputs will be XS. So we know that that's the first and only argument. And it's a collection. So I have a different enum here, which is the coercion enum. And what this will do is indicate what type of coercion is necessary. So I've defined three. There's the none, so do nothing, just let it pass straight through. And so this is maybe if you had, I don't know, some constant, or some scalar like 2, 4, whatever, that gets passed into your generic, so you don't want to do any coercion on it. Then if it's a scalar, like an integer or a string, we'll coerce that into a JSON object. And if it's a collection, we'll coerce it into a collection of JSON objects. So we're going to need coercion functions as well that will help provide that operation. So I can copy those in here, and they're pretty straightforward. So these are the coercion helpers. So we want to take the type to coerce into and the value to coerce. And if it is a scalar, then what we're going to do is just put the value of the scalar against this field called ID, property called ID. If it's a collection, then we need to convert the objects into strings of JSON. And if it is a pass-through, we do nothing. We just return the object itself. And then the opposite is true. So we then deserialize from JSON in both cases, and we parse to get an actual object back. So those are our two coercion helpers. Now, what we're going to need to do is construct the query to call that reverse function. So to do this, I'm going to have a new function that we'll call apply generic. And the reason I'm calling it apply is that's usually the word you use when you do function application. So we want to apply the arguments to the generic function. So what is this thing going to do? Well, we need to construct the query or mutation. We need to coerce the arguments. And then we need to call the generic. And we want to coerce the output if necessary. So let's refer back to our plan again. So our plan says that where we want a query, these are our inputs, XS, and our output here. And we are passing in the input to that we received in the lambda to this boilerplate function. So this is the main generic function. It will coerce things in an arbitrary way, and the assistant only needs to generate this little configuration object. Okay, so this code's a little mundane. We're constructing a string for this query. To show you what we're trying to create, I went ahead and wrote a little query in GraphIQL against this service. So the syntax for this is just standard GraphQL query, where you specify the name of the function. In this case, we want to invoke this function here. So it's reverse, and then we want to create a variable. So that's what the $sign means. And I usually just use the same name with the $sign, name of the argument, in this case XS. To indicate that it's a variable, you put a string in the string sign in front of it, symbol in front of it. And this is a collection of JSON, so this maps to the right type. And then you just do the variable assignment here. And then I added one variable, XS, and then two objects in there, 0 and 1. And this is what the scalars would look like. So there we go. It's giving us 1, 0. So this is exactly what we want to do now, but in code. So the first part is we have to construct this, and we need to do this for really arbitrary functions with generics and without generics. And then we have to do the coercion of the variables. So let's go back to Visual Studio Code, and I have written this out already, and I will walk you through the logic. So I'm going to be mutating this query object by reassigning it. So I've used a let here as opposed to a const. And we need to first start with the query type, if it's a query or a mutation. So that's in there, and recall the constant up here is query and mutation. So that'll insert that. And then we use the name of the function with an open paren. So we've got the initial part of the string. So what I did here was from the inputs, and we'll go back and look at the plan here. So from these inputs, I did this as a dictionary. So I have each key represents the argument, and then the value represents the type to coerce. So in this case, we're coercing a collection. It could be a scalar, and in the future, it'll be probably a function as well. So we could do function applications within generics, but that'll be in the next episode. So we're going to just simply iterate over, map over each one of the key value pairs. So that's the argument and the coercion type. And we're going to omit this. Remember, this is just the same. This is the argument with the string symbol, or this dollar symbol in front of it. And the type that we wish to coerce to. So this is going to be JSON. Recall that the constant up here is this. So that's the type we want to coerce to. And then we're going to just simply join them all together with commas so that you have a comma separated list. So that takes care of the first part of the string that we need to construct, which defines the variables and their types. So the next thing is the function with the arguments along with the variable. So that is simply done. Here. So we just add the close paren. So we're going to add this to the string and close the paren, open a new block with an open brace. And again, we begin with the function name, reverse, open parentheses for the variables. And the input values then are following the same pattern. We're going to iterate over each of the inputs and generate the argument with the variable name and do a join by strings. And then now we just need to close the block, query block. Here. Okay, so that gives us our query string. And let's just run this so that we can prove to ourselves that we are on the right path. So we see query reverse $XS here with the JSON collection, and then that should call reverse. So that looks like our example here, although slightly different format, but it's the same. So that looks good. Okay, so the next part we want to produce the variables. Get this comment here. So in this case, we're going to build up a variables object, and we're going to, once again, iterate over the entries of the inputs. For each of them, then, we want the argument and the coercion type, and we want to actually coerce the value. So this is where we use these functions here. So we get the type and the value. If it's a scalar, then we build up a little JSON object, etc. So we can just now map over each one of these to produce a variable, coerced variable. And that's all there is to that. The last thing that we need to do then is call the generic function itself, which is just issuing the GraphQL request and then coercing the output. So here is the service reference. We saw that in the coercion plan here. This is the service we want to call. Here's the query, which is what we just built, and the set of variables. So we'll get the result, and we simply want to do the other coercion. So here we just coerce from, we don't have, there's nothing to iterate over because it's a single output. So from the plan, here we've said this is also a collection, and we then put that in the result. So this should be all of the logic. We have the boilerplate up here, which has our constants, our coercion helpers, and then this function that can iterate over the coercion plan to coerce all the inputs, form the GraphQL query, and then call the actual CKG service, then coerce the results. Remember in our faker, we're assuming that it's the reverse function. We'll change this in the next episode to make it a little bit more rich, but we know we're just doing this for one case here. So all it does is reverse the X's, and again, this is JSON, so it doesn't care. And instead of printing hello, let me print the actual results. And let's run this. Results is not defined, it's singular. Okay, so we have Bob and then Mary. So that's exactly what we were hoping for. We have 0, 1 coming in and 1, 0 coming out. So we should have everything we need to cut and paste back into the lambda. So I'll take everything between the entry and the exit. We'll go back to Q. And now we have the implementation of a lambda that replaces all of this logic. So let's go back up to the function graph, top level function graph. And I will now create a version of reverse persons. This is the wrapper that is implemented as a lambda instead of this function graph. Reverse persons, we'll call this lambda. It's going to take x's person and return a person. And we want to just cut and paste now. Should be okay, just make sure. There's our return. And there's our entry. Go ahead and save this. And I will run it here just to make sure that we haven't screwed anything up. And it looks okay. We get Mary. So we now want to replace effectively this implementation here. This is not what we want anymore. So we can use our test driver up here and just swap it out. So I can bring in the lambda version of this. And instead of calling reverse persons, I will call our lambda version. Okay, this won't do anything. So now we're rerouting into this guy. And if I run the overall reversal, we should get exactly the same results. 1 is Bob and 2 is Mary. Okay, so now we have a lambda version and it's generic. So there's some boilerplate code. And then all the lambda assistant is going to have to do is provide this little bit of configuration down here to tell that boilerplate function what to do. So it's going to just provide this. So it should be pretty straightforward to write that assistant. Okay, in the next episode, we're going to get more sophisticated, build out some more tests, but we're going to do functions as first class. So we'll be able to do things like mapping functions, generic functions over generic things like lists of person and so on. See you next time.